In our last video, we stated some important log properties, so I'm going to quickly restate those here and leave you with a few new ideas as well. Last time we saw that log base b of x equals y can be rewritten as b to the y is equal to x. We call this first form the logarithmic form of the equation, and we call the form underneath the exponential form of the equation. So it's fairly common in homework, exit slips, textbooks to see something like rewrite this logarithmic as an exponential form or vice versa. An easy way to remember how to convert is the base of a log becomes the base of an exponential or vice versa. And then I'm just flip-flopping the other pieces. So for those of us who are visual, this is kind of an easy way to remember that relationship. So that's one thing. The other thing I just wanted to reinforce was understanding a little bit about our calculators. Most of us are going to have an LOG button and an LN button on our calculators, and those just refer to logs with different bases. So if I type in log of 100, it's understood that that's a log base 10 of 100. So the log assumes a base of 10. It doesn't have to be written for us to know that. Similarly, ln, if I see ln of 100, that's going to assume a base of e. So ln is a log of base e. So we have base 10 logs and base e logs where they don't actually have to be written, but the notation informs us. Other bases would be expressed. So if it was log base 7, for example, you would see the base of 7. So that's another just key thing to keep in mind. The last thing I'll build here, we'll keep this short, is that there's an inverse relationship between logs and exponentials. So in our next video where we will explore graphing, we'll see that graphically. But basically what we can say here is if you have a function composed with its inverse, this is something we learned in Unit 1, we'll get back just the argument, or the inverse composed with the function will give back just the argument. If I apply these ideas from Unit 1 to exponentials and logs, that would look like the following. I could have b to the log base b of x, so I have an exponential paired with a log. That would simplify to just the argument. Similarly, I could have log base b of b to the x, and that would also equal just x. So we're getting at this inverse relationship between an exponential and a log, and that's going to be another helpful thing as we move towards graphing. So with this in mind, just to clarify, I'll provide one last example on this page. If I saw a statement involving an ln and an e, this is one that sometimes we miss just because the notation might not be the most straightforward. So if I saw something like e to the ln of 3x, for example, remember that ln is a log base e. So e to the ln of 3x would simplify to just 3x because I'm pairing a function and its inverse. And going the opposite direction with that same kind of statement, if I saw the ln of e to the 3x, again, that's log base e of e to the 3x, so that would also equal 3x. So just a couple things to keep in mind, a few more details to add on to our understanding. Let's go ahead and dive into graphing now.